right, you guys, let's get started here. The next assignment that I've got to do is the locator. Let me go out here to this module. Let me just see where we're at. I need to do a video on this locator. So this is the first orthographic projection drawing. So it's going to be a little bit long-winded here just to get this first one, and maybe I'll do some over-explaining, and hopefully that doesn't confuse this. But this is, we're reading about multi-views and kind of how to view a 3D object. Maybe it helps to view a 3D object if I put it in a glass box and then I try to like move and I lock that 3D object up in the glass box so it can't roll around or rock around or whatever. And so it's like secured, and then that glass box has six sides, and really I can bring that shape up um to any of the sides and look at it like perpendicular to my eyesight. So I just like would move that glass box and look at one end of a three. And we do this when if I handed you the 3D printed part around the class, you could kind of like put that thing in orientation to where each side, each one of the six sides, I could look at dead on or kind of like perpendicular to those planes. And I would see features, and they would look different in one view to the next. Kind of the features would kind of change as I looked at all six sides of this 3D object. And so what we've got to do is kind of replicate that, and we're going to do it in third angle perspective, which means we're going to draw the three principal views. Let me look at the assignment sheet here. So let me pull it up, this locator, just review the assignment sheet. It's a 1108 locator drawing on ASME inch template, so all my dimensions will be in inches. We've got that template ready. We're going to use the B-size sheet for the orthographic drawing, and it's a 1:1 full scale using concepts of orthographic projection. Draw the three principal views, top, front, and right side of third angle perspective, I should say. Like in America, in an ISO or international standard, we might choose to look at the object a little bit different. And I have a demonstration class. We can talk about that. But anyway, this is to detail the locator object, and the resources you have are going to be a PDF of the dimensions. I think I already have mine open up, and that's actually where we're going, so I'll leave that one up. But here's my dimensions. This file is that one that you could open up that has the dimensions I need to even draw it. And so let me go back and just go through the instructions a little bit more. Yeah, we're not recreating this. This is how a lot of the assignments will be given to you in the future now. You'll just have you will just have an isometric pictorial given like this, and we will have to come up with the three views that I need to draw. These are already kind of positioned to help you lean towards picking the views kind of easily. So what I mean is this 3D view is already kind of dominant to three sides. Like I can see this surface plane, and I'm going to call this the front view. Anytime I see them, kind of they're at like it's a 3D object kind of at a 30-degree angle from my view, and kind of rotate it just a little bit so that it looks so that I can pick up that it's not just a two-dimensional object, it's three dimensions, right? So I mean that's really easy to see that this is three-dimensional, and so. But what I'm going to turn it into is views that are just kind of two-dimensional, and that's that glass box method. I'm going to build a glass box around this thing. And one of those sides, if I turned and looked at it specifically, would just be this surface like perpendicular to my eyesight. And my eyeballs kind of being like almost right on this plane. Like, what would that object look like? Well, it might look like just kind of like an L-shaped object is what it would look like. And then when I look down on this object, so this is the front view and this is the top view, kind of this surface plane here, or really the topmost view would be this little surface plane here. And I would look down from there, and it might look like I might get a lot of definition out of the top view of what this object looks like. I would see quite a few details, but there's some things that I would miss, and some things would be maybe sloping down and away from me if my eyes were on this top of this and looking down. And then I would have the right side view, which is if I put my eyeballs here, kind of perpendicular to this plane here, and just looked at this object, I would kind of be able to see this surface, and I'd be able to see this back surface, but it would be further away from me, right? And so that's the concept that I'm trying to help kind of help build this visualization of a, of orthographic projection, picking three views to define an object. Sometimes more views are needed. Like I have six views available to me to draw, but in a lot of cases, I want to draw the minimum views because they take time to draw, right? I want to draw the minimum views to show the details, and so I don't have redundant views. And so we're going to be able to draw this with a front with this plane in mind, a top with this kind of plane in mind, and a right side view with this plane in mind. And that's how this object is already associated in this pictorial isometric view. It's already kind of leaning me towards or guiding me towards picking those three views. If you picked any others in those, if you picked any others, then you would, so if I picked this as the front view, this surface and this surface and this one would be down and away, then what I would have is this being front, and then my right side view would kind of become back and away, and it'd be hidden in this, like in just the orientation of this 3D, that would be hidden. And I wouldn't be able, it'd be like I'd almost have to come up with what that information is on the backside. Like maybe I could figure it out, but I don't want to do that. It's kind of like mental gymnastics that I maybe want to avoid. And likewise, the left side view of this, if I've chosen this as front, the side that uh, this little line here, but the surface that's down behind there, it's hidden from me. I just don't even see it in this 3D object. It's like not a real clear view, the left side view. And likewise, if this is front, then this would be back over here, and it's totally buried. I'd have to have X-ray vision to kind of see it. I mean, there's some things I could figure out, and if I read my notes, so what we've got going on here is maybe the new thing that's been added is I do have a general note added. Specific notes are maybe dimensions and other uh, leader line, uh, multi-line text can be like specific notes to this specific object. General notes sometimes appear on the main front page. They apply to the whole print pack if this was multiple prints to show this and to detail this out. I might have a general note on the first page, and it might look something like this, with the notes being that 0.2 text size and the rest being 0.125 text size. That's kind of what's going on here. That's a normal ASME format. That general note title would be the larger text size. I always have two text sizes, 0.2 and 0.125 in ASME inch drawings. So I kind of figure like I have one size and I have the double size, even though we call it 0.2. It's a little bit of a lazy double size, but these general notes say dimensions and tolerances are per ASME Y14.5, 2009 code. Okay. There is a newer code to that. I think my newest book is 2018, but this one still is, it would still be applicable. Um, Everything that's in 2009 is in 2018. Maybe 2018 has a few additional new things that have been added between the years of the code books. Code books don't come out every year, so there's a period of time between code books. And anyway, remove all burrs and sharp edges. That means maybe this is going to be machined out of metal. Maybe it's 3D printed in plastic. But either way, if these edges, like however good this gets cut, maybe the edges would be sharp to handle and they could injure me if I didn't know and I didn't have a glove on or something. So I would want to make sure these are deburred. And that's all that is, a general note to deburr the sharp edges of this. Sometimes machine tooling does create a pretty razor sharp edge, and we would want to just knock that off to keep people safe. The part is symmetrical from front to back, and that's if I'm already assuming that this is the front. That means the back is symmetrical. That means what that means is if I could take a cutting plane, like let's look at this center line, halfway between the front and the back of this part, and if I could just view like cutting this, I think of that movie like is this Cake? What is that one where they slice anyway? Hey, you'll just hear me talking to myself, but I'm just recording a video, dude. So you're totally welcome. Yeah. All right, I think we're back in. Let me just make sure we're on my screen. Yes, good. There it is. So the last one is that the part is symmetrical from front to back. And so, yeah, if I have that cutting plane line established down through this part from front to back, the details of the front side from halfway over are the same from the middle over to the back. The same couldn't be said if I cut this in half from kind of right side view to left side view. So if I feel like maybe even using the center line as the cutting plane line, if I cut that or somewhere wherever middle point is from this surface to this left side buried surface, if I was actually to cut across through that, it would not be symmetrical from left to right. The right side has this slot going on. The left side has some weird notches in this backside, totally different features. But if I did cut it the other way, it is symmetrical from front to back. So that's something that's good to note. And that just the reason why that's on there is because some of the dimensioning on this particular part, they're shown to the front view favored side. And they're implied that they also, by having this general note, that implies that they also are the same on the back side. So let's jump in here and start drawing this. What else? This is what we're going to end up looking low. These are the three principal views of that part showing an orthographic projection. So we've got a front down here, bottom left. We've got a top view. We've got a right side view. And they actually align, perfectly align, like edge to edge. If I was to take a ruler, and like line this up, the principles of orthographic projection are some of the details that I put in one view, I can just project to the other view, and I don't always have to measure out. And I'm not individually creating each view, is what this is. I'm gonna create some of one view, then I'm gonna project those features up to another view, and then I'm going to help that detail in what it looks like. And that keeps things in alignment, and that makes it so. The reason why we actually do this, like the whole gist of why we do this, is because it'll minimize how many dimensions I have to do. Like I really need these three views to adequately describe and dimension this object. But I always don't have to put all the same dimensions from one view to the next. I can actually dimension one view, and then through orthographic alignment, I can imply that those dimensions are on another view. And so I use this strategically to minimize how many dimensions I need on a drawing, and then to show things in orthographic view. And this makes the viewer happy. They can visually see this alignment. They can see the dimensions that we will eventually start adding to drawings, and how they cross relate between views. And the nature of that is I use a lot of this in between area between these two views. I use a lot of that area for dimensioning so that I can apply those dimensions to the next view. All right, so that's kind of where we're headed long term. Short term is we just need to learn how to draw these and how to make these views talk to each other and help us kind of like draw in features from one view to the next. So let's try this. It's a little bit this is going to test your visualization from one view to the next. But this is essentially how this part would look if I was to look at three views kind of perpendicular to their plane. Perpendicular to the front, perpendicular to the top, and perpendicular to the right side would look like this. If I could actually hold those objects in my hand, that's what it would look like with those projection or with that angle of a viewing angle, I guess. Yeah, I think that's right. So let me show you how I begin this. I begin this with kind of the concept of building like a glass box around an object. And so I'm going to jump over to AutoCAD. I'm going to open I'm going to open my template file, which is inch. So I'm going to use my 2025 ASME inch DWT file. I'm going to open it from my file. This is going to become a drawing just by the name. I didn't open it from CAD, so that's going to maintain it. It's a DWT file. I just opened it from my file. It turned it into a DWG. I like that feature. I'm going to save this as a new drawing. I've drawn this one before. It's called the Locator Ortho. I might call this Locator Ortho in class. And we will probably do some of this drawing in class together anyway, if I can get it right. Okay, good. I've got myself a unique name to draw. Eventually, it's going to end up on our B-size sheet. I don't need to worry about that yet. Let's just come out to the model and start figuring out. I'm getting my bearings here. There's my origin point. I'm just going to draw in this area. I do a lot of construction line work with these drawings. So I like to build, yeah, let me just see for a minute. Oh, that's good. I just want to make sure that everything is, I got it turned on. I have a bad habit of not hitting record. I'm going to try to prevent that. Let's see. Oh yeah. So what I want to do is kind of define the size of the right side view, sorry, the front view, define the size of the top view, and define the size of the right side view. So I kind of use this glass box method kind of a boundary for where those views live. And I can look at this I can look at this and come up with what is the overall, if this thing was just like if there was a rectangle that could encompass this or one of the glass panes from a glass box, how big would that rectangle be that this thing would fit inside? And I look at the dimensions, I say, well, it would be for the front view, and I generally start these from the front view. The front view is this kind of master view in orthographic projection. It doesn't mean it's like always got the full, it's not I need the other views. Like the front view is limited still, but it is this kind of master view that I tend to start from. And I definitely build my orthographic drawings from the front view, uh, with the front view established. So if I look at the front view, the overall dimensions are 2.5 by 5. And so if I had a box that was 2.5 by 5, I can guarantee that my front view would fit within that. So that's kind of what I draw first, is I'm just going to, on a construction layer, I'm going to draw a rectangle that is 5 by 2.5. That's fine. I'll just leave it right there. It's totally arbitrarily placed in my model space. But my front view is going to fit in there. It's going to be kind of like an L-shaped view because that piece is kind of an L-shaped part, has like weird features going on. But when I'm looking at this as the front view pane out of the glass box, yeah, that means really the features that are on the back view, rear view are going to totally align with the front view because the part is symmetrical from front to back, meaning that I'm going to kind of visible line detail the front view features, and they'll probably be perfectly in alignment, or they will be, not probably, they will be in perfect alignment with the back view features to where we'll have some alignment. I mean, I have to still visualize this view is 3D and there's parts of it that go away from me. And so I am drawing a three, even though this is a 2D front view, I am considering the 3D nature of this object. And I have to consider that. We didn't have that in any drawing until now, but even when I draw here, I'm always visualizing that it is 3D. It's an actual part. It has dimensions. It has measurements in all three directions. So keep that in mind. And then how else we set this up? That's the front view bounding box. What I want to know is maybe this, how big is the window pane on the top view? So I'll jump over here. The top view is maybe a little harder to tell here, but it's actually, if I had a rectangle that could fit all of the top view in, it would be 5. It'd be the same kind of width as the front view, and it would be like 3 inches kind of deep from the front view. So the top view, and I'll come up with the right terminology. I feel like this first one I always forget, which there is the right verbiage to say what is width, what is length, what is height. And I think the two that I get mixed up are maybe width and length. So let me think of what. So anyway, what I need is a rectangle that's 5 by 3 that's orthographically aligned with this. So I'm gonna pick like another rectangle, and maybe I'll draw it from the bottom right. Uh, or it doesn't matter. What I'm gonna do is I'm gonna just kind of like keep things in alignment this way. So I'm gonna kind of use my cursor alignment, and maybe I will do top left actually, like I normally would do a rectangle. And this thing is gonna be this size of a top view. It's gonna match this length of the it might be that this is considered, I don't know. I'll figure this out. But so I might say it wrong in this first video, and then I'll get myself figured out. But um, this is going to be the same kind of overall uh, length here in the front view. This length that's 5 is going to be the same in the top view length. So I can actually make this match, or I could enter 5. And it's going to be 5 tab by whatever width this is. And it was 3 inches it was 3 inches in our measurement. So 3. This is a 5 by 3. So the top view will fit in here. And a 5 by 3 rectangle pane. That's how big it would be. Everything in the top view is going to be able to be bound by this boundary here. And then the right side views, the right side view, now that I have kind of two view panes built, the right side view will kind of establish itself. But let me show you how it does that. It uses a miter line to establish this. So with this bounding box of the front view, what I want is I want a line that comes off of it at 45-degree angle. I want like a 45-degree angle miter line from this front view. So what I do is I come down here, make sure I'm drawing in 45s. I need to draw that. I'm on 30, so I'm going to draw a 45 line from this top corner of this window box here. I just want it to be 45 degrees, and I need it to be, I don't know how long I need this to be. It's actually a projection plane is what it is. It's going to project features and data from the top view kind of around this corner to the right side view. So I'm going to just pull this kind of long because there's a couple things I need to know here. I kind of already mentioned that when we establish these views, we like to leave room in here between the views for dimensioning generally. And so I kind of already want to have that in mind, even though we're not dimensioning these. The spacing that I have between front and top might be sufficient. It would be totally sufficient just to draw these objects because my object's visible line work won't extend beyond these boxes. They will be bound in here somewhere. There'll be a bunch of lines that we draw. But in the reality of like drawing this and dimensioning it, this is where a lot of dimensions go, and this could be crowding this. And so what I like to have a little bit is the paper layer that we have. I could draw the area that I have to work with on my B size print. So let me show you what I have to work with. It's this size, and I really have anything that's inside the border to work with. I'm going to use a single viewport on these. So I know that we can also zoom in on a model with multiple like views and bring those in. It gets a little trickier when I'm trying to keep multiple views orthographically aligned and I'm using multiple viewports. So right now I'm going to avoid that and try to get these orthographic views in one viewport. So that's going to be my way I proceed for quite a while in this course. Just kind of use single viewport, keep in mind how much room I have to work with. And that's what I'm going to do right now is just kind of plan ahead a little bit and say, what is this distance? Like technically in this drawing, I only have 9.5 inches by it's 16, all right? Because we came in a half inch on each side of a 17-inch piece of paper. So it's 16 by 9.5. That's really my workable area that I have to get all my views in. So if I jump back over here, I can use that paper space concept or my paper layer, I should say, and a rectangle to maybe just like I'll just draw it over here. It's going to be a piece of paper that's with a boundary that's 16 by 9.5. That's all the area I have to work with to get this done. And so maybe I'll move this over my objects now. Everything is just pre-planning here. And maybe it's going to look like this. Maybe I'll move up. I don't want anything to be like super close to this. I want a little bit of space, but I don't need to measure what it is. It's okay for me just to like kind of take a guess and maybe it'll be something like, oh, it's going to end up something like this, right? I'm going to have a right side view. But what I look at here is that, yeah, this is sufficient space between maybe my borderland and where my object definition might start. Maybe this is a little tight. I have a lot more room here, and I do know that dimensions are going to fit in here eventually. So I'm already going to plan that this might be wasted space right here. So maybe I'm gonna move this particular top view. I'm going to move it away a little bit. Like I don't know how far I'm moving it. It doesn't really matter. I just want to use up some of this space and create more space probably between the views than I have on either side of the views. But it doesn't, I'm not measuring these out. I just want to kind of just do it like an eyeball check of this. Like, okay, this would work good. If I have a right side view over here, it's easily going to fit in my one-to-one size on my paper space. So in my layout. So I feel like this is good. What that dimension is, I don't know. It's probably not something that's like super, it's some weird, it's almost 2 inches, but it's some decimal, and that's fine. If you moved it 2 inches away, that'd probably be really good. But this is sufficient. This just shows me I've got more room in here to work with dimensioning. And that's going to be handy. And how we actually establish where the right side view fits is just with this, that's the magic of this miter line that I just drew. And what we want to do is, and let me show you how this works. These two views talk to each other. So right now I'm already going to be able to tell that front view is going to make sure it's orthographically aligned with the top view. That means, I mean, these two dimensions, they're shared between between front view and top. That 5 inch is the same. Well, just the 3 inch is shared between this 3 inch depth, height for sure, length, I think, and I think width. The the one that I may have to check is this considered width or is this considered length? And is this considered width or is this considered length? It's going to be in your book, I bet, because it is, and it's good to know that. There could be a lot of questions on quizzes where that's not. I'm actually pulling up my book right now just to see if that there is something that shows that. In your chapter 8 is where I'm looking. Chapter 8 is what you're working on. This is where I'm glad I checked. So and I feel like I mix this up sometimes when I instruct this, but definitely height. That's clear to know. In the front view, we think of it as elevation or height. That's height. This is considered width, not length necessarily. This is considered width of the front view, the width. So this would be the width of the top view this way. And the last thing is depth. Is this? This is depth, and the depth of this is the right side view. And I guess that makes sense, right? Like if my front is my primary view, kind of this master view that has like part stability and clearly represents most of the details, there's not a lot of, I mean, the way I evaluate which is the front view is like it's got good part stability and it has maybe most features shown, fewer hidden. I wouldn't want a front view that I chose that has most of the stuff on it is hidden, like it's not in the plane of where my eyes are. And I'd have to have X-ray vision to see. But that is the depth. So there is depth associated with that front view. And that's what I pick up in the right side view is the depth. So I pick up height, width, and depth. And I think you've got questions on your quiz where it wants to know which one's which. And so I don't want to mess it up either. So I'm glad I've kind of like looked that up. Height, width, I'm looking, yeah. It's definitely chapter 8 stuff. Yeah, that's good. Height, width, and depth. I feel like I always want to use length, and it's just maybe not something yeah. I don't know why. I like the word length. I just don't get to use it, I guess. Height, width, and depth. Height, width, depth. Okay. So how I establish this though is I use this miter line. Whatever I project across over here and then I project it down, it's going to maintain the same kind of dimensions that are in the top view. So what I mean is like this, the same way I projected this one up to here, it's clear that these keep the same dimension. And whatever I, this box, it's 5 inches. If I project it up, it's 5 inches here. That's actually how I built that box and I've kept it in alignment. The same way here, like I'm gonna actually project this over to the miter line and where it crosses is what I'm trying to pick up. And then down, straight down, like there. And I'm actually going to target this and pull over and say that this is how far down the right side view goes right there. You can use ortho mode. I feel like sometimes when I toggle on ortho mode, it gets a little crazy on the snaps. Like I'll show you, like that seemed pretty good. I could easily keep, at the 0 degrees. I've looked for that intersection. I have this particular object snap on. Sorry, I just turned them all off. I'll turn them on. I have intersection right there is what showed up as my object snap. It looks like this. I have polar tracking on or object snap tracking on right here, my object snap tracking. So when I pull that line across without ortho mode on, it looks like this. And I feel like I get I can see the 0 and I can see the intersection point at 0. So I feel like I get a nice orthographic alignment there. If you use ortho mode, let's do that with ortho mode. That just means F8 is on, or this little right angle down here is ortho mode. And let's do that same concept here. So I'm gonna snap here, come across. I definitely get it to kind of go crazy on me a little bit because it wants to snap to a point that's outside of its ortho mode ability. So if I use this, it's a good way to keep things straight up and down. Sometimes I just pull beyond. Like this is not going to let me draw anything that's not horizontal or vertical. So it's going to make this thing be horizontal. I sometimes just pull, I don't have a snap to go to, so I might just pull it long like this and then trim it to fit. And then, so that's maybe just an extra step. So, like I said, I've said it before, I use ortho mode, but maybe I use my polar snap tracking to different angles and my object snap tracking. I make sure those are on. I probably use those more than ortho mode myself personally. And because then what I would do is I'd pull where that intersection point is down straight. And then I would target this just so I pull it the same length and pull it back. There's that intersection. Great. Essentially what that means is this is now 3 inches. This is 3 inches deep here, just like it's 3 inches deep here. That's this is called a miter line, and we use it as a projection, kind of like a projection plane. It's like a mirror almost, like it's like over and then down. Yeah, like if I shot a laser against glass. Yeah. I can just trim this extra. I didn't know how long to make that, so I made it arbitrarily long, just so I could definitely span the that depth of the top view. So I get that there. I'm going to come back to here, and I'm going to do the same kind of projection from the front view over to the right side view. It'll help me lock in the base of this. Sometimes I click over, then I might click here, then another line here. It's probably not totally necessary, but then I have this depth, so this is 3 inch here. And then I might do that for the top. I need to know how high the end, the height of the front view is the same as the height of the right side view. So I just click over here, click here, click here. And what I've done is kind of just extract three boxes that my views have to fit in here. That's that boundary that they'll fit in for sure. And it's kind of using their associated overall lengths to build where they are. The nature of these are is that yeah, this is going to become pretty heavily with dimensions in the future weeks. And so the further I get more room to work with if I push the top view away from the front view more. You can see that. I mean, I have my borderlands kind of like, that's what my paper is showing me. I have some room to work with. There are some dimensions that show up on each side of these too, and sometimes they show up on the end. A lot of my dimensions end up between the views to kind of infer that they are shared dimensions between views. So this becomes our heavily dimensioned zone. But I do also want room to dimension if I need to off the lefts and this back sides here. So I don't want to just take these clear out to the borderland. I like to leave space for add-on dimensions. Because if everything gets too congested in this area, I can always snap a dimension outside just for clarity's sake, right? Clarity is keying, even though I like to infer a lot of like in between dimensioning. Anyway, and if I move that top view away from the front view more, it'll push the right side view further away from the front view. So, this relationship I can actually increase by pushing this view away, and that would naturally make my miter line a little bit longer, and that would make my projection of the right side a little bit further away from the front view. So you can use that strategically. I'm not looking for a specific dimension. I'm just looking for it to fit, leave me room to work with, and fit on my paper in the end. In this case, a 1-to-1. This is going to fit for sure. Okay. Now we get down to the dirty work of drawing the object. And I usually start with my front view. What we'll do is we'll piece in what information we have with the dimensions we're given. You always end up lacking to be able to complete the view from one. And so then that's why I project whatever information I was able to detail. I'll project it to the next view and then start to draw it. And then I'll project it. I tend to work in these objects. I tend to work front view until I kind of hit a dead end. Then I project whatever information I did in the front view to the top view, and then I kind of like draw that in, and then I take that information over to the right side view. So I kind of and then sometimes there's some stuff that I picked up in the right side view that I then have to project over to other views. So it's kind of like this circular from view to view that I'm kind of bouncing around to, but I don't build them separately is the key here. What I do some of it's time. It seems a little time consuming at first to do it this way, but it eventually becomes kind of a quick method of once you figure out information from one view, just project it over, and you don't have to like remeasure stuff. You don't have to maybe make a mistake. You can just use orthographic projection to help you detail the other view. And so we want these three views to communicate to each other. So I'm going to start with the front view until I hit a dead end. What I'm looking at is this drawing. I'm visualizing that my eyes are on this plane, looking across here to the depth of that. And what I would see is I would pick up this surface for sure, but I wouldn't be able to tell in the front view that it's sloped. I would just kind of see it as this, it would look like this kind of weird little number 7 shape because it's got a notch here in the back. So it's got this. Yeah, this is gonna cause us some problems probably because there's no dimensions to it. There are slightly some dimensions, and if I really analyze the dimensions, let's see what I got to work with. I've already used 5 by 2.5 for the overall. If I just let's start at the bottom here. Um, I come in a quarter, and then this surface plane actually picks up. So it actually from that 5 dimension clear over, really my object surface that I'm viewing from here comes in a quarter, and then it's this long, and then it's 1 3/4, and it's kind of falling away from me. If my eyes are on this plane, I would see this, but it's like falling away from me. It's like got this depth perception that I can't tell. But I do know that it's like at that 1 3/4 inch mark is where that's kind of that's falling away from my eyesight here. What that's creating is like foreshortened lines, the difference between foreshortened and true length lines. And I'll say that a lot in this video. But in the front view, this surface plane is going to be foreshortened in my view. It's like my eyes are on this plane. This little bevel miter is like falling away from me. And so we'll kind of talk about that. But I got some dimensions to work with there. I got a 1/4 inch in. This height goes up, and then I hit this point. This I don't really have. I have some dimensions associated with it. I have some extension lines coming off of it, but nothing in the height column, right? I just don't have the height of where that is. So I don't know how high that is from the bottom up to there. Likewise, I don't know where the height of this is either. I have no dimension off the height. It would kind of be on this dimension plane here. And so I don't know where that is. So there's going to be some limited data on this notch that I can work out in the front view. I can just tell that. Um, the 1/2 inch and 1/2 inch dimensions are a little bit misleading if I have to look at them really close. But if I'm on the top plane surface, I see that this is 1 inch. Then I go over a 1/2 inch, and that's where this one kind of starts. But it's really a 1/2 inch from if I stayed on this surface here, it's a 1/2 inch over. And it really, this thing goes like down and away from me, and then it starts. So however long this slopes to that point, it becomes a 1/2 inch kind of in the top view, but it really doesn't measure a 1/2 inch because it's like this is like a nice little triangle that it builds right here. But this is actually the hypotenuse of a triangle, and it's kind of longer than this little edge, this side of this triangle here. So that's confusing, I know. We'll come back to it. And then from there over, it comes over, and then you pick up this dimension that's a 1/2 inch. But that is what's misleading, is that this dimension, while it looks like it's on the same surface, it's actually lower because it comes down clear to like here. And it's essentially maybe picking up from the last little bit of this surface that I can see right here. And it's the remaining that's over 1/2 inch to there to this surface. So really it's a 1/2 inch from this surface to this surface. Then it's a 1/2 inch from this surface to this point here. So really this is like 1 inch, even though it looks like, whoa, how can that be 1 inch? It's because the dimensions give you a weird optical illusion that's going on here. But it's like it's actually from like if I were to measure this front side and I could bring this line down, it's just like 1 inch over, then there's 1 inch, and then there's another inch. So this thing's only 3 inches wide. So this is misleading a little bit. What it does show is that slope from the top is 30 degrees down. So that's a helpful dimension, but it just doesn't help me in the front view know where that terminates when that slopes down from the top view. I don't know how high this is. Either that or that. These are the mysterious points. I do know that this little ledge comes in a 1/4 inch. Like this slot cut out of the back is in a 1/4 inch. So there are some, I mean, I could pick up. So what it looks like is this. Let me show you. I can kind of visualize this, and you have this little cheat sheet right here ready for you. It's going to look like this. This is what we're going to recreate. It's like 2.5 inches tall. Yes, it's 5 inches. It's 5 inches. Sorry, 2.5 inches high, and it's 5 inches wide. And then I think I have this dimension. It's like maybe 1 inch. Let me go back and look on my paper. Yes, 1 inch. So that is 1 inch, which means that from here, that 1 inch to this total surface right here, from the bottom to this little surface is 1 inch. Then from here up, it's an inch and a half for sure. That's what's left over. And how far over is like this from, yeah, this is 1 inch. It's like a little quarter inch here. Then this is like 3/4, and that all equals 1 inch. So I feel like I can kind of pencil, I can kind of draw in right over the top of my boundary that I made for it. I can start doing some visible line work. And what it looks like is this. It looks like it's from this, the left side would be this solid line, 2.5 inches. The bottom would be a solid line, 5 inches. Then it's going to go up 1 inch. And then it's going to go in all the way over to here, but it's like this is 1 inch. So I think we figured that it was 1 inch kind of L shaped, like the whole thing is 1 inch over here. So that means that this over here is going to be 4 inches. And then it's going to go back up to the top and then it come across over. So that's kind of what it looks like. But there's features in here that are, I mean, there's miters going on in here that are kind of like not, they're not, I'm not perpendicular to them with my eyesight. They kind of fall away from me or they're just moving around. I mean, there's just features that aren't perfectly on plane like this to see. So there's like this thing miters down from the top towards me and it hits a point where it stops and then it comes down to where I'm parallel or perpendicular to it. Same way with this little thing, it this edge of this actually isn't on my plane of view. It's been mitered a little bit. It's further away from me. So what I need to, and I know that was one that I could pick up. So let me think here. Right, like this edge that I've actually drawn is really not on this plane, this surface plane. It actually falls away a little bit and then I pick it up. I would still see it at the 5 inch mark, but where it kind of tapers and comes away from me is what's going on at that 1 3/4 right here. So I should have this visible line like this, where that surface then falls away from me and becomes this surface. This surface and this surface, there's a little bit of a miter, and it doesn't give me a degree of what that is. I have no idea. I might be able to figure that out. Maybe it's not necessary, but they're not on the same surface, right? And that's clear to see here on a 3D object. What it looks like in 2D land is it looks like this. It's that visible line right here. That's where that surface falls away from this surface. And I can see that here. That's where it's falling away. So let's draw that in. Back on CAD with a visible line. It's essentially, I'm going to cursor over that 1 3/4. Cursor it over to there, and then I'm going to draw this line perpendicular. I use perpendicular a lot. It's one of my object snaps. It's this one, perpendicular. It shows up as like a little right angle. It doesn't show up as a T. It actually shows up as a right angle. That's perpendicular. That's where it is. That's the difference. Those two surfaces are not, there's a break point there where this surface breaks away from this one. Okay. The other thing I knew that I could pick up was a line that's like a 1/4 inch over. So from here, I'm going to cursor over a 0.25. And I have this notch that kind of goes up and maybe I'll just draw it up to the top. It doesn't quite go to the top like that though. Just by the nature of this drawing, it kind of ends right here, not clear up to there. So, but I don't know what this dimension is. So I'm just going to leave it long and trim it later. And so I'm kind of starting to have, I'm at least starting to have the object line work done in the front view. Other than this surface up here in this top part is not on the same plane as this surface. It kind of has that difference here. So I should have a hard line here where those surfaces, it more looks like a number 7 surface right here. And I'll look at my cheater sheet here, like that. I just don't know what that is. And I can't figure it out from the measurements. But I will use orthographic projection to figure it out. I'll tell you right now where that's going to come from is this information from the right side view. But I haven't even started drawing the right side view yet. But I could technically like bring those over and it might help me. Like that one is what's going to help me figure out where that line is. These two are in alignment. It's funny as I cursor over it, you don't think they are, but they are. They're in orthographic alignment, and that's that point. I'm not going to go to this view right away. I mean, I could, but I think I'm going to go to my top view. I tend to work kind of like this way on the start of all these. So I'm just going to leave this. I'm going to say I'm going to abandon ship. I've done some detail work. I feel like I'm out of I've got some things to figure out for sure. The other thing that's on the cheat sheet is there's a few other line types here. And what these are and I'll put these in last. I tend to work visible line work first, then I kind of jump into like what's my hidden line work, and then I might jump into center lines become last for me really in the working process. I feel like I'm working like visible line work and hidden line work for the most part. So green dash is a hidden line layer. We haven't used that. We haven't used that line type or that layer yet, but we will here. What's that? What that is picking up in the front view is how deep this little slot is. So this slot feature is really not on my viewing plane um, on the front view. It's actually something that I would have to have X-ray vision to see, and really it's even kind of confusing. Like if I only had this view, I wouldn't be able to make sense out of it. Technically, I know I've got the line types correct, but if I only had that view, I'm zooming in like I only have that view, but I wouldn't be able to know what's going on here. I might get the feel with the center line that there's a roundness feature going on, which is actually what I'm trying to communicate. There's a round feature. It's actually this round feature looking at it this way, though, right? Totally different projection look. And so this is kind of I would need X-ray vision to see this. And so how we kind of denote X-ray vision is hidden line work. What that becomes is like the apex of this slot right there, the quadrant, that apex point would look like that's kind of the terminating end of how deep that slot is. And it would kind of look like a line in the front view. That might be hard to see at first. Give yourself some patience on that. But I'm actually not seeing any of this curvature. I wouldn't be able to make out what this is from like this point and around. It would just look, it's just this curvature that I can't tell in the front view, even with hidden line work shown. I don't need to detail any hidden material there. It just is happening. It's kind of like what's happening here is that, the the plane is changing from where I'm viewing, breaking away from my view. So, but I really can't tell that here. It's just like, oh, it's another surface. It's another surface. Something, with only this view, I can't tell that there's a turn of that part. I wouldn't know what this visible line is, but that's that break point. Same way with here. I'm not picking up like all of this. There's really no features here that I'm picking up, but where it ends, that point of tangency, this is essentially like a point of tangency, but it becomes a line. We'll put it in later, and I'll probably project it down from the top view to put it in. But let's zoom out a little bit. Okay. There's my cheat sheet. I think I'm done for a minute. I can't quite figure this out yet until it comes around. Let's project up. Let's project the features I have of the front view up to the top view, though. So the first thing I do once I put in those information, rather than just work in the top view from scratch, I might already jump to the construction layer and project up some of the features. Like I'm going to need these. Like I'm going to need to know this. This is a feature that I've defined in the front view. I'm going to project it up to the top view. And I could project it clear across. It's not wrong. I could project it here and then pick it up and go the rest of the way. Or I could just do like remember, these are construction lines, so I have a lot of leeway in how I use these. It's whatever makes sense to you. Sometimes with this, I might project up and come clear across. The only reason why is because I'm drawing on the front view, but the back view is like symmetrical, and so I might need to know where some of where the attributes are that line up on the back view, and so I'm just going to pull that clear across. I do a lot of crisscrossing grid patterns with my projection lines. It gets a little bit busy, but anyway, this point I need to know in the top view. Maybe I'll just bring it across. This point I'm going to need to know as well, and so I might bring that up and across as well. I've already defined this feature that I just, it's not quite right, but I know that's a 1/4 inch. Okay, so I've got some, so I think that's it. So that's the only details work that I put in the front view. I projected them up and across. Now let's take a look at what they mean here. Well, what they mean is, I'll go over my visible line work, and what that means to me is I'll just kind of start with like the base. To me, it means that this corner I've got some weird stuff going on with. Let me look at my right. Like I've got kind of this notch out of here, and I kind of know that notch is a 1/2 inch. It's like a 1/2 inch from this surface that I'm viewing in the front view to this surface is a 1/2 inch. I pick up that when I look down on that. What I see is it looks like what it looks like is from here it comes in like a 1/2 inch, 0.5. I'm cursoring over to that point. And then it would come this way, and then it comes this way. And then it comes this way to that point, and then it goes this way, and I don't know how far it goes that way. I don't have that. I think I can figure it out. Let me see. But what I've just created is where that little notch is. Like it was a half inch in, then it came over, down, and over. That's kind of what's going on. The same thing's going on from, that this is where the front surface looks like a line in the top view. So what's going on in the front surface as a line here is also going on in the back surface as a line. They're in alignment when I'm looking at the front view. The back features are actually in total alignment here. So essentially what I can take is from the back side here, I can draw a half inch, 0.5, and draw over here to there, nice and perpendicular, and then down to here. And then I'm going to go back to this line here, which is where this feature is. Sorry, this feature right here. It ends right here. And then I would have this would be a visible line work to there to there. That's that leftmost surface. So that might be a little unclear. And what I end up doing a lot is I like toggle off and on my construction line work. So I'm starting to piece in the front view. Here's my little cheat sheet. See, that's what I've done is I know this from my measurements. That's a half inch up. It's a quarter inch this way. That's why that slot looks like that. These little slot cuts are on the cut away from the front surface and from the back surface. They're cut in there a half inch, half by quarter little cut, little groove, almost like it slips into something and slides up and down. So, and then that is just the leftmost surface right here. So that is just where I drew it. And then what else would I have is the very topmost surface. Like the only thing in the top view, if I go back to the pictorial view of this, the only thing that's really on the where my eyeballs are like looking and perfectly perpendicular to where I'm looking is this. This little surface is the only thing that's in the top view. Everything else falls away. This surface is, an inch and a half lower than where I'm actually looking at the top view from. So my eyeballs are right up against this in the top view. So I'm going to draw this little 1 inch square. It's a 1 by 1 square. Let's put that in. That's a feature I can easily draw in here. Maybe I'll turn on my construction work but really it's like this little square from here to here that's 1 inch, and it's kind of off of center. So I have some midline work. I have some midline snaps that I can uh, use. But what I might do, because I'm not going to try to do a bunch of overlapping lines. I've already got a visible line here, so I might come to the midpoint of that. That's the middle part. And sometimes I do put the midpoints on because I need them. I already put this line in, so I have a midpoint. I actually have double midpoints here because this particular line has the same midpoint as the white line. Anyway, I have that grip. I'm going to cursor any direction like 0.5. And then that correct? Let me see. Maybe that misfired on me. From here up 0.5? That looks more correct. And then it goes over to that. That's where it drops down the inch and a half. So I feel like this is going to come over to here. Then it's going to be an inch this way, and then it's going to come back this way an inch. That's that little square on top. Without overdrawing this, like double lining it up. I kind of just drew that, drew that, drew that, and I left that. I think that's all that's going on here. What I need to know is from that point to there, how that is. I know that it's sloping to this point. Let me go look at the dimensions and see what I got figured out here. So kind of this I need to like where this is like this line represents where the right side view looks like a line, and this is the right side view surface. So let me show you. This is the right side view front surface. And that's how, did I already tell, that's how to interpret these is that these are already pre kind of set to drive you towards looking at a front, right side view, and top view, because all the other views are kind of hidden from you. The bottom, the back or the rear, and the left side are kind of not visually clear. So I'm already kind of driven towards front, top, right side. So this is the right side eyeball viewing surface. And from it, the depth of this is 3 inches. It comes in a quarter. That's that dimension I was looking for. It comes in a quarter, and then it's whatever, and then it's one, and that's whatever and a quarter. So I can kind of figure out what these are too. They're not explicitly given in this, but I've got a 3 inch overall, 1 inch there, quarter and a quarter. That's a half. So really, I'm like 3 minus 1.5 is 1.5. Half of 1.5 is 3/4. So these lines are 3/4 of an inch. Then that makes sense to me. Um, a quarter plus 3/4 is one, then one, then a 3/4 plus a quarter is one. So that all equals out. While those dimensions were given, I can kind of clearly see essentially it's 1 inch from there. And if this block didn't have this going on, if it was just squared corner, that'd be a 1 by 1 by 1. So I'm gonna pencil that in. I always say pencil in, even though I'm snapping lines. I'm gonna snap some lines in for that. Where they are is like this is the outermost. This is this edge right here, right? Right side surface is a line. Right side surface is a line here. So I'm gonna come up a quarter of an inch, 0.25. Well, I had the wrong. I couldn't cursor up the right way there, but I like to lock in there. There we go, 0.25. That's better. Then I told myself that it goes 3/4 of an inch. That's that line. And I can do another line from that point to this point. That's that. Yeah, I already had this point feature projected up from the front view. I went over a quarter in the top view, and that's where that line is. This is what you call what I just drawn. This is called the true length of this surface. Looking straight down on this surface, where this surface appears as a line is what I'm seeing in the top view. That is what is called the true length. In this view, in the front view, this surface, it appears as a surface here, appears as a line here. This is called foreshortened. That means from this point to that point, it's actually sloped away from me. And what we call that is foreshortened. And that's like, I'm going to beat this to death all semester long. That is a foreshortened length. If I actually snapped a dimension there, it would be inaccurate. It would not be the true length of that line. Where I could snap a dimension if I needed to know what the distance of that surface is, would be the top view. This has the true length shown right here. So this would be where to snap that dimension if I needed that dimension. This is the true length of the dimension. This is foreshortened. It's falling away from me. I can't see that. It's a 3D object that's placed in a 2D, in perpendicular to a 2D surface. I end up with true lengths and foreshortened lengths. And that's why I actually need multi-views to define and to be able to dimension. We don't dimension foreshortened lengths. They're kind of worthless to us, actually. But what I need to know is that they're not worthless. I just need to know when they appear and when not to dimension to them. And so this is not a true length. It's falling away from me. Just like this is not a true length. It's like the topmost surface where my eyeballs are. This slopes down and away from me till it hits the front view. So this is called foreshortened as well. Where I will pick up the view of, or the true length of that is going to be in the right side view. So I use those views to define true lengths. Let's do the same little jog up here. Like I'm going to come down a quarter of an inch. And then I'm going to draw this as 0.75. And that's that first line. And then I'm going to snap the line from that quarter inch back to this point. That's because if I had a cutting plane line through here, the front half of this is symmetrical with the back half of this. And then what we have is a slot going on here. This is like those terminate. This is an inch across. I should be able to measure this distance between where I ended that line and started this line. That's an inch. That's good. I like that. Double check yourself as you go. Then I need to know how deep this slot is, maybe what the radius of it is. Let's take a look. This drawing, right? Okay, so I pick up some dimensions right here. It's an inch across, that's good. It goes in 2.25, and then I pick up the radius of this, and this isn't explicitly given. There's no leader line with what that radius is. It's kind of left for you to figure out. How do I figure it out? Well, it's that 1 inch. This is the diameter of that circle right here. This is a 1 inch diameter. So technically this is like a 1/2 inch radius. This goes over 2.25, then it has a 1/2 inch radius over to this point where it's 2.25 out. So it's kind of like a half a slot. Let's go draw that in. I think I have the information I need to draw. I actually have the starting and terminating points already. So I already figured out that this is where that one starts. It goes in 2.25, 2.25, enter. And then it ends, right? Then it actually radiuses around. So I don't know. Let me do the other one from this point that I already have over the same amount, 2.25, which I can either type in or just do this. Okay. Maybe I'll just put in a construction line for a minute. So I have a center point of my circle. Like I'll just connect these two together. This has a midpoint in now. So now I can kind of use this midpoint of this line to be the circle to pick up the rest of it's essentially half a circle, right? It's a semicircle here. So I can use a full circle, maybe radius. That's a snap. That's a midpoint snap. Right here, right? Midpoint. So that's a snap. Let's do circle from midpoint. And I could actually grab that and snap that. I could enter it in, but you can also like if I have this, I can snap to that. That's a 1 inch diameter circle, just kind of based off the grips and my construction lines that I had. I only need half of that, so I'll trim out the rest of this half. It's terminating on that point of tangency. That's why it wouldn't let me do a single section. Hey, there's the slot. Hey, sweet. That's good. Really, I'll toggle this off now, and I might be done with the top view. Oh, I think there's something missing here though. What catches my eye is that I knew that this is on the front surface, the topmost surface where my eyeballs are. Then it kind of drops away from me 1.5 inches and goes down to this surface. So technically this surface and this surface, they're not on the same plane. They look like they are here, but they're not. I've got this jog. This is where that surface. So I should, from that projection line up, I should snap a line across. So I could do it segmented because I've got partial shown. But what I need to draw in there that's obvious is that I need a line that goes from here to here. And then I need a line that goes from here to here. Now when I turn this back off, I mean, turn off, that looks right to me. That's the visible line of this surface right here, right? Surface is a pair of lines in different views. Technically, that surface is would show up in the right side view, but so that surface would, geez, I like talk circles around myself, but that's this surface right here. It appears as a line in the front view, even though it has this going on with it, that all kind of lines up in the front view. And then it appears at a line in the top view too. Like this line appears as a line in the top view. That's kind of what I just drew in. I drew it segmented because I already had this line and this little line right here and this line are they're perfectly aligned when I'm looking down on them from the top view. That's why I already had partial. So when I jump back over here, that's why really they're kind of in alignment here. Like there's this line that represents the top little square, and then there's that line also is overlapping to that 1.5 inch drop from there. You get a lot of alignments here. Like a single line represents multiple kind of like it can represent multiple termination points of like surfaces and stuff. So you get that alignment, which is handy for dimensioning, but we have to be able to visualize that top view is three-dimensional. This object is three-dimensional in this view. So I always have to remember that. Okay. But long story short, I sometimes have to turn this on and off to make sense out of it. It gets busy, right? Okay, I'm ready to project information over and start detailing the right side view. I might take a quick look at this to kind of make sense out of the right side view. My eyeballs are going to be right here. They're going to look like two little squares. Then I'm going to have this that shows up like I'm going to be able to see down this slot to this back, but it's probably not going to look as a circle. It's going to look like a kind of like a square. The top makes it look like a circle. The front makes it look like it's hidden from me. I can't even see it. From the right side view, it just kind of breaks up by two little squares here. And then I'm also going to have this edge here. It's like a 1/4 inch off. So I'm going to have like a line and a 1/4 inch away. I'm going to have this other line. So these little squares are in a 1/4 inch and then they're in. I'm also going to be able to see this, like this shape, even though it's not going to be on the plane of eyesight here. I'm going to be able to see this. There's nothing blocking it. I'm going to be able to see this little shape right here in the right side view. This surface will show up in my right side view. That'll help me to have that. And I can probably project a little 1x1 square over to my right side view, and that'll help me like use that 30 degrees to my advantage to start picking up some other details that I might need to take back over to the front view. So let's go start putting some of this in. This might be a little unclear to see, but when in doubt, I can draw more visible lines than I need, and then I can kind pencil them in later, I guess. But I can do what I did on that. I can do what I did from front to top. I can just start projecting features over. So I think that's a good rule of thumb. I know that I'm going to have these little square features show up in the right side view. So I've already got the outermost surface projected over. There will be some visible line work on the outermost surface. Like this surface that appears as a line here is going to be appearing as a line here. And that's actually the rear of this surface. So I don't know. I feel like getting there into the right side view is where I probably start to confuse people, but I'm going to project this feature over to the miter line and then down to the object. And maybe I'll just go down clear across and I end up with this like crisscrossing grid pattern. I'm going to do that again with this feature. I'm going to project it over to the miter line and then down and crisscross that in. Yes. I have this feature as well. I'm going to project it over and down. And then, well, I could have kept going with that. Maybe I'll pick it up again and just drag it. I don't want to keep it. I want to keep it in orthographic alignment, make sure I don't pull that, and then snap it. Yeah, because I think I'm drawing these as like full length all the way across. Yeah, I am. And the last one is this little feature here is going to hit that miter line and project down. And essentially what I have is starting to block in those features, but now I have to make sense out of what I just did. I just kind of took this information that's on the right next to my eyeballs that I'm perpendicular to that surface as I'm looking. That surface is perpendicular to my eyeballs, I guess. And those little squares are going to appear there. They're an inch tall. Well, guess what? I have the height of them right here. And if I just project them across, that's them. They just kind of they figured themselves out. Those are those two little squares that are the pretty much the right side most surface that's right by my eyeballs. And this little section here is what this surface looks like as it's falling away from me in the right side view. So this actually represents a surface that is severely foreshortened. It's actually this long, but it looks like this. That's a great look at like what a foreshortened, how foreshortened can really be bad. There would be no way that I would snap this dimension. It's only a quarter inch in this view. It's actually this long, but it only, it's a really severe angle here. So what I mean is I'm ready to pencil in some visible line work. What that looks like is it might even I might draw this. This is a little I'm going to draw it from like the height of this. I'm going to just draw it all in. And then across the bottom, I think I'm just going to draw the whole bottom that I would see. And then across this height here. And maybe I'll just box this whole thing in. Like that's me kind of retracing over. And now I'm going to make sense out of this that this point I've already projected across. So it kind of comes clear across here like that. And that's kind of the surface of this. That's that. I just drew that line clear across. It actually has some alignment. This edge right here and this edge are in total alignment in the right side view. I actually just end up drawing that all the way across, and those pieces are part of it, right? They're right here. Then what we have is the slot. This is a hard edge. Like I see this and I see this other side. And I see this where that foreshortened. I'm going to turn off my construction lines for just a second. See how that looks like that? That's kind of what it looked like. This is the surface that my eyeballs are on. This is that surface that's like what is it, 4 inches away from me. This surface is kind of the back of the slot. Like it looks like a square, but it's actually round back there. I can't tell that from the right side view. Like sufficient, that part of the slot is actually well defined. These are the edges of the slot right here. This line that's a surface is actually this line here. These little rectangles, like I said, are the foreshortened look of what that's going on here. I would see that hard edge and I'd see the outermost edge here. That's why it looks like a rectangle here. Really skinny one. That's the surface that's way falling away from me in the right side view. Okay. Another thing, I'll turn back on this. One thing I want to make, I think I could project these features over. And I do think that this is a 1 inch square. I think this is a 1 inch wide slot, and they're both on center. So technically, this in the top view is in alignment with this. I can kind of show that if I go over to my construction view. And if I actually drew a line from this feature and I wanted to take it across, you can see that I'll actually be lined up with that one. So technically, this projection line kind of does multi-purpose for me. It's kind of like this one coming. I mean, if I can draw this over here, we didn't pick up that line until here. I don't want to really draw this because well, that's a wrong type of line anyway. It should be a construction line from here over to there. They're aligned. So what I'm going to do is I'm going to use this. I don't know. It's like this is where that hits the slot. But those are in alignment. This little edge is in alignment with this edge here. Same way with this. You could toggle on ortho mode and snap to there. Yeah, that shows that these are in alignment. So that came across is really where that 1 inch little square that's where your eyeballs are in the top view. That's where that 30 degrees comes down until it hits this edge here. This line is the front view surface. It appears as a line in this view, but it's actually this surface. So essentially, with that in mind, I have what I need to use 30 degrees to my advantage. It's from here down 30 degrees. And what I want to explain here is that you have to look at angles as kind of like they're positive and they're negative. Not, I shouldn't say that. I think of it as like imagery, like oh man, that's even funny because nobody knows film anymore, I guess. It shows my age that I remember cameras as being, anytime you get your photos developed, you'd have a negative. They give you your negatives, which they can make new photos from your negatives. So I feel like in a way, that's what I view. Like I have depends on which way I'm referencing the angle is which angle. What is the degree of that angle? Well, it depends on which side you're referencing, right? I feel like it's the Cheshire Cat in Alice in Wonderland. That's a really old show, but it depends on where you come from is what that angle measurements. Depends on where you want to go. Kind of depends on where you came from. That's the Cheshire Cat. Alice asks the Cheshire Cat which was the right way, and he's like, "Well, it depends on which way where you want to end up." That's that's kind of funny. So what I'm saying is I need to draw a line down here from this surface that's down 30 degrees, and you can see that I could just tab over and hit 30, but that's not exactly what I need. See, that's 30 over this way because it's referencing this as being 0. That's 30. So I have to think of like I think these are called supplementary and complementary angles. Supplementary, this might dust off some, means that two angles that add up to be 180 degrees. And complementary angles are two angles that add up to be 90. So I have to think of either side of that sometimes when I'm working with CAD. The other thing I can do that I use instead of having to do that mental math is I use my polar tracking. Um, this my polar tracking settings to just help me figure out those angles easy because I can select those angles. I'm on 45 and 90, which means if I'm actually in a line command and I've picked a point and I want to draw a line, I can get 180 is essentially the same as 90. So I get the snap tracking to show up there. Then as I pull away, the next one I'm going to get is like a 45 somewhere. There it is, 45 degrees. Shows it up as 135 in my thing, but if you think of 45 plus 135 is 180. That's a supplementary relationship between two angles. Or what I kind of think of as like, which depend, what is that angle measurement? It depends on where you measured 0 from. CAD essentially measured it from kind of clockwise. And it depends on which way of horizontal you're going. If I pulled it this way, it's going to call this 45. It's going to call this 90. Either one of those are not fine enough to find a 30 degree. So what I have is options here. 30 is an option I have. So this is good. I'm going to choose 30 as my polar track. I'm going to make sure that's on too, that I've chosen 30 is checked. That's good. Some of these are redundant. Some of them just become really fine. Like 30 shows up again here. 15, 30 is 45. So this is a really good one. It's just that it has a lot more like when I get into the line command, what's going to show up now is 180s or straight across horizontal. Then the first one I get should be 30. There's 30. The next one I should get should be 60. There's 60. Then the next one I get is 90, and then I get this way another 30, kind of how I can think of that. Another 30, another 60 somewhere there, and then back to 180. So I like that these I don't have to do the mental gymnast, I don't have to for this particular part, I don't have to do any like calculations of which side, tab over and what do I enter in this one? I don't know. Let's just use my track setting. So I'm going to say 15 or sorry, 30 is there. That's what I actually want. 30 and where it intersects the surface that's the front surface right there. Yeah. And I'm gonna do the same thing over here. Repeat that from this point down to the first one that hits is 30. And then I might just pull it back to where it's intersecting there. So hopefully that made sense. What's when I look at this, what doesn't make sense if I turn off this is that my object isn't that shape there, right? It looks like this. It's actually this shape. So I need to trim out some of that. I've kind of overdrawn, and that's fine. I do this quite a bit. I'll be like, well, that's fine. I blocked it in. Now I know where to trim it. I had that intersection point that I could lock into. That's actually the shape of it. It's 30 degrees down from the top. That thing's 1 inch across, 30 degrees down where it hits the front. So that's kind of handy. It's not totally done though. There's some features that are hidden in the right side view that exist on the left side view that like if I did a left side view to expose these features, the notch here, it's really totally X-ray vision necessary to see it in the right side view. And there might be some circumstances where this happens and I do need to draw a left side view. I'm not going to have to here. Sometimes when it comes to dimensioning is when I make that ultimate choice. Because the rule of hidden lines, this is like a golden rule, ASME rule. I don't put dimensions to hidden lines. I have to either dimension to center lines or visible lines, object lines, but I don't dimension to hidden lines. So that doesn't matter to me now. I'm not dimensioning. But what I do need to do is put those features in. I need to show how this notch is. I should be able to, like, if I'm looking through this part, I want to be able to see those features represented. They'll just be represented as hidden lines because they're not on a surface that my eyeballs can see without seeing through material. Because this is a three-dimensional view. So anything that's going on in it, whether it's on my surface or not, I need to detail it. And that's what our hidden line layer is totally for. Hidden line is green, hidden line 2. It's a really light line like our center lines is a 0.13 millimeter line weight. So they're light lines, and where you see them is on the cheater here, right there. What we have is these two lines coming down. They just represent where that slot is, right? Where this notch is cut. So this surface right here appears as a line here, and I can project that over where it hits the miter line, and where it hits that, that surface is going to be represented by a line here too. But it's not a visible line. It's buried in my view. It's buried in the part. I would need 3D view to see it. I can kind of replicate 3D vision by putting in hidden line work. And so this surface I need to account for in this view. Let's do that then. Let's go there because I think we're pretty much done with object line work. And it looks pretty much like I've got. So let's do some hidden line work now. That's kind of the way I proceed too. I'll do my object line work, and then I might jump in to see what features are hidden in that view, and let's get them identified. So maybe I need to turn on my construction layer again and jump over to my construction layer. So I'm just gonna, I've never projected that data across to the miter line to know where it is here. And I don't have a measurement. I kind of do though. Technically, I'm going to use projection, but you are able to figure it out from a measurement because it's a half inch over. And that's a half inch over kind of like when I'm looking from the right side view, or I would at least be, have my eyeballs perpendicular to these surfaces. I'm looking that way, perpendicular. When I say perpendicular all the time, I mean because the surface is like right here, like a wall that I'm looking at. In order to see that wall, my eyesight's kind of like perpendicular to it, not parallel with it. If I was parallel with a wall, it would look like a line kind of. But when my eyesight's perpendicular to a wall, it appears as a surface. That's so maybe that helps explain when I say perpendicular, my eyeballs are perpendicular to that. Anyway, what was I saying? Oh, yeah, it's a half inch over is where that is, but I'm just going to use projection to define that. I technically could measure over from here a half inch and then down, and that's where the hidden line is. But I can also use the concepts of, projection. That is the nature of why we even do this, is to say, I already defined that here. I don't need to measure it out here. Let's just do some alignments. This is the feature. project it over to the plane, the cutting plane, or this miter line, sorry. Oh, I might have pulled that one out of alignment. If you do that, just watch yourself. Or use orthograph, or use the ortho mode. There's zero, zero and intersecting. Ooh, it's really close to a center line. I think this is what's pulling me off, is that. So this would be a good case of where I might just say, stay on zero, pull past. I don't want to snap to the wrong snap there. Maybe I'll trim this now. TR for trim if you want to use your keyboard. You'll just see I use the ribbon menu a lot, so my videos, so you don't see my keyboard motions as much. This one goes down from here, down to where it hits my object. Past this, that's actually just reference material. Down until it hits here. There is a center, there is a midpoint there. I don't know if it lines up. I just want to make sure it's orthographically aligned like this. I'm not worried about it. I don't. So watch snaps. You have to watch snaps. Especially I have to watch them because I keep so many on all the time. I have to be careful. I'm going to do the same thing. This feature is going to come down and across as well over to here. That one's easier to pick up. There's no midpoint kind of giving me problems. I pick up the intersection point there pretty easy. And then I'll come down. Maybe I have the same issue here though. If I come down, yeah, it's just going to want to snap, and I can't verify, I can't vet for sure that, see, I feel like there is a difference in from being perfectly horizontal. Here we go. We'll do ortho mode. That's perfectly horizontal. It's close, but I don't know. It might be the same point. I'm just going to pull it past and trim it like that. Excellent. That is where those hidden lines come down. So I'm going to go to hidden line layer. I'm going to do a line. It's already got a pre-loaded line type, line weight. From that point, maybe the end point, that's what I need. I think they are in alignment, but I can always shift select as the end point, bypass that midpoint, and then that's where this comes down and terminates here like that. That represents this surface. This surface has not been totally well defined here. This is going to help me. I'm going to project over and lock in these features that I've been able to figure out from the right side view. I need to repeat that line here. Hey, that's picking up an endpoint pretty easy. That's good. And then down to here, perpendicular. Good. Those represent that notch in the back. From that, I can project across to the front view. These points, I've detailed them here. I'm not dimensioning to them, so but I use hidden lines to project from for sure. They come across here. Maybe I'll just take them straight, clear across. Enter. The other one is this one. This is a feature that I figured out from the right side view. Let's bring it across. Maybe I'll just bring it clear across. Now I need to decide what that was. Well, that's that sloped surface here, right here. It's foreshortened in this view. So what I got to do is come back over to my visible line work and kind of piece that together. It's actually like this is the upper one right there, kind of ends there. So this comes across here. It kind of ends that surface. Then it gets to there. This one I initially pulled long, so I can trim that. That isn't there. That's like that. And then it comes down to here where there's another hard line here. I'm going to go back to a line from there to there. This should look like a little kind of number, I don't know, like a number 7. Let me look at it. Turn off the construction layer. Yeah, it looks like that. I didn't have these heights. I couldn't really define that, but I figured them out from over here. They projected them across. That one. This one I figured when I dropped that 30-degree in, it projected across and created this line. This one, when I projected those over and down where they hit that sloped line, I projected them across and figured out what that was. And then the jog is just the two surfaces that are in there. This surface and this surface look like this. The visible line work is done. That looks correct to me. I've got some hidden line work done here. There's more hidden line work to do. It's this, I should be able to see like that. Initially, I talked about that, the apex of that slot or that very quadrant of that. So I'm going to turn on my construction layer again and jump over there and maybe project a line down like this apex point here, which I have quadrant on to get there. Oh, maybe quadrant isn't what it is. Picking up a midpoint. That's fine. That's what it is. Midpoint. That one projects over and down across here. And that's really an X-ray vision from front view to see how deep that slot is. Like it's not on my surface, it's depth of material. My front view though represents 3D objects. So let's put some hidden line work there. Hidden lines are not like center lines. They are bound by I mean, because they represent actual features of, they're not like this. So they are bound by visible lines, right? Like this goes from visible line to visible line because that actually is a feature. That feature doesn't extend beyond the actual thing. Like center lines break this rule because they're not a feature. They're just something that helps me visualize round and they help me visualize a lot of stuff. But let's see. So that's good. There's some hidden line work there. What I need now is probably some center line work, and maybe I'll turn off my construction layer for a minute. Like the one that's obvious that needs a center mark is this circle always needs a center mark. So I could use the center mark and say this circle gets a center mark, just like it would in our other drawings. It gets a center mark with 1/4 inch extensions in inch ASME standard. And that would probably be fine. Like I think if in my cheater sheet, let me take a look at it. Yeah, pretty common that I would pull this out, probably because there's going to be a dimension that lines up here. If you leave this as just across, no big deal, like no harm. Maybe I'll pull this through because generally slots have their center lines from one end of the slot to the other. This is a partial slot, so just for like I think good drafting practice would be to say, well, this is kind of like representing a slot. So that's probably why I've drawn this way. Eventually, when we go to dimension it, it's likely you can dimension to center lines. You can't dimension to hidden lines. So center lines grab dimensions all the time. This is probably going to be pulled out for a dimension there. And but this looks good. I like this. Kind of shows the nature of this slot is like nice, straight, and true. Those have 1/4 inch extensions. What I also like to represent is that this is the apex of a round feature. So I like to know that I represent that there's roundness going on by dropping a center line here. It doesn't make it immediately clear if I'm only looking at the front view. It's a little bit still confusing, but I like to it's a visual that there's some round feature going. And in when I have the top view to look at, it's like an eyeball thing that I'm like, oh yeah, I see that. That's the center line of the radius of that slot. And so I'm going to drop in the center line here, which is aligned with this, which I can do with some projection. I can turn back on my projection lines, and I could project from the center down and through here. And that's actually where the center line of this round radius feature in the top view is, right here. So I can jump over to the center layer and just do a center line. I know we use center marks a lot, but I could just use center line here, and this gets drawn in. The only thing is center lines do need to extend past the visible lines a 1/4 inch. And so this one is the one I can draw it bound in by the visible lines. And then I can just like grab the grip and you can see I've got access to how far that's the highlighted box there. It's just a 1/4 inch past that. So this gets a little tedious. You'll do a lot of this adjusting those center lines to go beyond the visible lines. Sometimes they're grabbing dimensions, but even so, this one falls into the same criteria that I want it to be a 1/4 inch past that. Even if I wasn't grabbing it with a dimension, I'd still leave it long like that. That round feature is also in the right side view. And I can kind of show its roundness. It kind of falls into the same category of this. This gives me some information, but it is a little bit confusing still. The top view definitely helps me visualize that. Same here. I want a center line here. That slot is technically like the geometric center of this, between front and back side. If I cut down here, this center line is really truly in center. That slot is centered in the part, we would say. And so I can even turn this off for this little next technique here, though. But yeah, we would say that this slot is really, it's centered in the part. It's equal distant from the back to the center of slot as it is from the front to center of slot. That's why I could technically do a cutting plane line across here and draw that. I didn't really use a lot of mirroring or whatever when I'm doing this. It's because these views represent 3D objects and I have to be a little more careful using mirror commands or whatever. I technically could have, but I'm using projection to define these. But What it means is that this is that round, like this surface that I'm seeing right here is just this curved surface right here. So it's best that I show that with a center line. And I could do the same thing what I did here, just project that over and down and center. Or I could even just line up to the midpoint of this line that's probably on the center. But I want to show you one more trick. Next to the center mark, I don't think we've used this yet, is the center line. This works as long as the feature um that I have the two that I have like two sides that are and my center line is going to snap right between them. And so these lines represents the surfaces of the slot here. These lines, these are these lines here. So I can choose this center line command. I'm on the center layer, and it just wants me to select a first line and a second line. So I'm looking for a center line in between. It's what it's asking is a center line between two lines. So I pick this line and I pick this line, and it snaps that center line between those two. So I love these two functions. And then this one all it has the same criteria that I need to be 0.25 and 0.25. There's only two extensions on that single line like that. I didn't use that technique here because I'll show you. This is not like this is not, these are not centered. This is it might be that it kind of looks like it is, but that is that point. It has really nothing to do with the center here. So I'd have to be careful using this and this to place that center line. Likely, it looks like it just so happens that the way this view is that it is. Yeah, I could have done that, but it's not thinking of the geometry correctly to do that, snap that center line there. I'm thinking of that center line being on line level with this, and there isn't another side of this. If this hole continued all the way around, I could have snapped both. I would need yeah, that's a good point. If this was not a slot, if this was just a hole, then I would project this 9 o'clock uh, apex point quadrant, and I would project the 3 o'clock point down, and I would have like two hidden lines. Then I would be able to snap a center line between those. But this technically measures the same, but that is not what that feature is. That's nothing to do with the round feature, is all I want to say. It's misleading. That's why I approached it a little bit differently than I did this. This is definitely halfway between those two surfaces there. So this really finishes this drawing, right? I just need to go look at the drawing, probably rename it. Um, I generally turn off my construction layers. I don't like to delete those even if this got really busy and now I'm ready for the next layer of maybe I need more. Anyway, I'm not going to go into that, but that's pretty busy. I just turn it off. I don't like to delete it. Just turn it off. I might delete this. This paper really is just holding me bound into that. This is what it's going to show up kind of look like on my drawing. Right now it doesn't. If I go over there, it's because I haven't scoped in on this on the viewport, but I don't need this. I'm going to delete it. I just kind of used it strategically for a minute. This will all fit on my paper one to one. That's kind of what helped me keep it in one to one. So let's go over to the paper now and zoom in on it. I have a locked viewport generally always. Unlock that thing. Maybe I'll scroll in, scroll around, find my part, make sure it's at one to one. Maybe pan this over. Oh, anytime I scroll, sometimes I pan when I mean to scroll. I could make my viewport a little bit bigger, but I don't really need to. Like it's not cutting off any of my center lines there. And I'm just looking for it to be, oh, just roughly centered. Yeah, like that. Lock it down. This is what it's going to look like without the grid. Yeah, this is going to look good. Definitely some line type scale. I could definitely change here, right? I'm at a one to one. I can kind of see now the hidden line type looks really good. So that hidden two on a one to one small little part that we draw, that hidden line is nice. The center lines aren't. And I think we're kind of getting used to the line types needing to be adjusted. So 0.5 here, I think will do good. Yeah, that's a nice breakup of a line. I can do the same thing here. It's a 0.5 line type scale. Yeah, it breaks that up better. And I think I can just do a match properties now from this to this. I think it'll pick it up. Yeah, that's good. That's sufficient enough. I get a little bit of breakup line. The cross kind of breaks up. I don't really play with the cross or the gap size there. I let it be like that. That's good. I need to change the name, right? Gotta adjust my name here to be our assignment. This one is it's a CAD 1108 locator. CAD locator, my name, new date is today is the 16th. Yeah, and then I'm going to take a look at the Control P and look what the print pre or the PDF preview looks like. It looks pretty good. If I look at this, I feel like some of these they don't you don't get the maybe the object ones don't pop. They're there. Maybe I'll zoom in just a little bit more. There they are. So they will show up on the if I plotted this, if I printed this, my object lines would I think look like this. I just noticed on these particular drawings, maybe that is a little misleading. My border pops good, like the line weights, but that if I zoom in just a little, I get that to pop. These don't. That's good because they should be pretty fine lines. Those hidden and visible lines should not pop like that. That's good. I'm gonna save this thing, I think. Yeah, I think I already have this saved. Um, week 4. What is this thing called? The Locator Ortho, right? Locator Ortho. I think I'm calling this one in class. Yeah, so I'll have one more dash here. Whoops, Ortho. What the heck? In class, CLASS. Get my hand on home row. Okay, love it. I'll save that. There's my PDF image. Still doesn't look like the right line types. It will plot to the right line types, I think. I think my internet browser kind of, or my Adobe does the same thing to me, where I have to kind of zoom in to see the actual line weights sometimes show up. But just check that yourself. Good. This one's done. I knew it was going to be a little long. Get this, you always get this prompt when you've done a PDF that everything like worked out okay. But yep, I knew it was going to be a little long. These first ones are a little long to really discuss how to get those views. I would upload this drawing, DWG file, and a PDF of this, and then call this one good. So we'll catch you on the next one.